All right, so today what we're going to be talking about is trigonometry. And I know that y'all have been through several walkthroughs of trigonometry, but I think that in physics we're going to have a little bit of a different perspective on how we use trigonometry. And my goal for today is to kind of take y'all to a new depth of knowledge on trig. And so, rationale. In physics, guys, we will be using trig a lot. You always have two types of physics classes. You have a trig-based physics class or a calculus-based physics class, and this is a trig-based physics class. But the main use is going to be vector analysis, and you don't know what vector analysis is yet, but we'll talk about that later. So, in order to successfully do that, guys, we have to have a really good working understanding of trigonometry. And so today we're just going to kind of go through and just review and make sure everybody's good. So what is a trig function? In every right triangle, if I have any right triangle that has the same interior angles, we call that a what triangle? Same interior angles. Not necessarily congruent. Congruent is if it's exactly the same size. But you're on the right path. What? That's if they're all the same to each other. I mean, if I have two different triangles and they have the same interior angles, we call those similar triangles, right? Okay, so for any similar triangles, the ratio of the sides is always the same, right? Okay, so in other words, if I have something that's, if I have two triangles, maybe one's small and one's big, if those are similar triangles, if, let's say, this side is twice the length of that, well, then I know this side's going to be twice the length of that in similar triangles, right? Okay, so a trig function, and don't worry about that. Essentially what we've done is they go through and they've cataloged, if you have this angle, because we just said if you know what the angle is, you know that it's always going to be the same. The ratio is always the same if the angle is the same, right? Okay, so if you have a 30-degree angle, then I'll always know what the ratio of the sides is. The ratio is. Okay, so a trigonometric function is essentially just a data collection of the ratios of the sides. So for a 30-degree angle, I know that the opposite side is half the length of the hypotenuse. Okay, that's just, they measured it and they said, oh, what's half the length for a 30-degree angle? Bam, collected that. Okay, so we have three trig functions. The first, well, 6 trig functions, but we're going to use 3. The first trig function is the sine. And as y'all know, guys, the sine is the length of the opposite side. Okay, when I say the length of the opposite side, I mean opposite of the angle. Okay, so if I'm talking about angle A, okay, then the opposite side would be the side that does not touch angle A. And it's the length of the opposite side over the length of the hypotenuse. Y'all agree that if angle A is 30 degrees, then we just said that the opposite side is always half the hypotenuse. Okay, so what's the sine of 30?
That over the what?
Well, if it's half over 1, then it would be half. Okay, so the sine of 30 is half, because if you have a 30-degree angle, then we know that the opposite side is always half the hypotenuse. Okay, and so what we do is we just take that, measure a whole bunch of them, plot it out, and when we plot it out, what we get is this graph here. Why do you think 90 degrees is 1? Think about it. Yeah, so the opposite side of the 90-degree angle is the hypotenuse, and so it's the length of the hypotenuse over the length of the hypotenuse, which is 1. Okay? Why is 180 degrees 0? That's a straight line. Yeah, you can't take the sine of a straight line. Okay, so that's sine. Cosine. Cosine is the length of the adjacent side of the length of the hypotenuse. Okay, adjacent meaning next to. Okay, so if I'm talking about the cosine of angle A, then I want the side that touches angle A divided by the hypotenuse. What do you think is the relationship between sine and cosine? In terms of angles. If I have the sine of 30. Okay, let's say angle A is 30 degrees. Then that would be the same as the cosine of 60. Okay? So in other words, these two angles are always going to be, what's the word? Complementary. Okay, those two angles will always be complementary. My way of remembering complementary and supplementary, and this is cheesy but always works, I say if you compliment me, you would be right. All right, good. Sorry. All right, so when we plot out cosine, that's what we get. Why do you think the cosine of 0 is 1? Okay, if the angle is 0 degrees, okay, then I have a flat line where I have the adjacent being the same as the hypotenuse. Okay, so that would be the adjacent over the hypotenuse, 1. Okay, and so as this increases, then this angle, as the angle increases here, then this bottom is going to get shorter, and so then therefore the cosine function should get smaller. Make sense? All right. So last one, tangent. Tangent is opposite over adjacent. Think about it, guys. When will tangent be 1? When opposite equals adjacent, right? Okay, and when opposite equals adjacent, I have, what's the name of the triangle? Isosceles. Okay, an isosceles right triangle. So tangent of 45 degrees will be equal to 1. And that one gets a little crazy. We good? Okay, so I'm going to skip through this because y'all know this, and we'll work on this in a second. But the easy way of remembering this, guys, is SOHCAHTOA. There's another way of remembering it, and I can't believe I'm going to say this on video, but I'll just do it. It's some old hippie caught another hippie tripping on acid. So that's another one. But if you use SOHCAHTOA, then you have sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Or some old hippie caught another hippie tripping on acid.
That's hydrochloric acid, right?
No. I don't think you can trip on hydrochloric acid.
I think we got it.
All right. Y'all know that, right? Nothing new. Okay, so what we're going to do is a little activity, and you're going to develop your own trig functions. And we're still going to call them sine, cosine, and tangent because we can't get that creative. But I'm going to let you get with a partner. Okay, so grab yourself a partner.